to another E node B, and also interworking with 3GPP. So basically that would cover the scenarios where we have the user movement between LTE and pre-LTE UMTs. Okay, so we cover both. Okay. And we have another session that will talk about interworking between LTE and 1X video. Okay, that's a separate one. Most of you probably have been attending this, or most of the sessions. But in case you are attending for the first time, here is my picture that you can relate voice to some image. Okay, now, so we have faced some problems recently while using PowerPoint format. Okay, so we need to find another way of doing the polls. So what I would request you to do is change the color of your seat. Okay, so I will just write here the color of your seat, and please provide me feedback that way. Okay, so please change the color of your seat to reflect the type of work that you are doing. I will give you 30 seconds to provide feedback here. As to the PDF file. We have another separate PDF file that has acronyms for the entire series, so that would also be helpful. So again, if F5 doesn't work, then we still have a couple of other options. Okay, so please use those other options. And if you can still not view the full screen, then communicate with Diane Easter and she will help you. This is what we want to accomplish today. We'll take a look at various handover mechanisms that are available in LTE. Within an MME area, when we go from one E node B to another E node B, then how we take care of the handover. So that's the overall scenario that we will look at. Unfortunately, I do not have control over the screen size. For me, this is the maximum screen size. Okay. So I think you would need to do that locally. So Dan, if you could please help that student.
Yes, I had been speaking before and was on mute. Didn't realize it.
Oh,
somebody had put a suggestion in the question to select view from your toolbar. So in the upper left-hand corner, if you select view, there is an option to go to full screen mode. That works for me. So for those who are still having difficulty, try that. Again, the upper left-hand corner, drop down view, and then the first option is full screen mode. Click on that, and that should bring you. But Nishith can't, the way he's sharing it due to some difficulties we had on Tuesday, he cannot make his screen larger. That will have to be from the user. So hopefully that helps.
Okay.
And then, okay, there also, someone has given an additional note from the view drop menu. There's also panes option, which may help as well.
Okay.
Thank you.
Very good. Thank you. In terms of the core network link between SGW and PGW, we have two options. We have GTP tunnel or we have proxy mobile IP tunnel, GTP or PMIP. So we'll take a look at that protocol stack. And for the intra-memory handover, we will discuss various steps of handover. We will also discuss the idle state mobility. In the idle state, we do not have dedicated radio connection, but the user may be moving from one area to another area, and we need to keep track of the user location, and we do that at the level of tracking area. So we will discuss tracking area concept. Also, how the LTE works with pre-LTE UMTS system. So we'll take a look at the interworking also. So those are the main topics that we will cover today. And as I have said in the past sessions, please maximize the use of the questions box. Okay, you can submit as many questions as you wish. No limit on the questions that you can ask. Okay. And asking questions is the best way to get maximum value out of your time investment. Okay, so maximize your return on investment. Okay. See, what it will give you gain or loss, but here there is nothing but gain. Okay. So ask a question and you will gain. Okay. Mobility. As far as LTE mobility is concerned, we may be experiencing radio access network mobility. So, for example, going from one cell to another cell in the same E node B. So that would be intra E node B handover. Within the E node B, we are going from one cell to another cell. We may have inter E node B mobility. Right? So in that case, we are moving between two E node Bs. So that would be another type of handover. Now, in both the cases, we are talking to the same core network element, MME and LTW. So there is no change in the core network element. We still have the same MME and same SDW before and after such handover. So that's why it is called radio mobility. The core network has no change in the element. So same MME is serving the user before and after handover. Same serving gateway serving the user before and after handover. In contrast, the core network mobility means that there is some change in the core network element. So some node will change. Either the MME will change or SGW will change. Okay. So for example, when we go from this base station to this base station here, maybe this E node B was controlled by the serving gateway 1, and now E node B2 here is controlled by serving gateway number 2. So it means that we have different serving gateways taking care of different E node Bs. So when we do the handover, then we have a change in the core network element. In this case, serving gateway is changing. And whenever there is a change in the core network node, it is an example of core network mobility. So we will consider both the cases. From the perspective of the core network, we have registered state and deregistered state. So when our UE performs attach operation after power on, then it attaches itself to MME, Mobility Management Entity. And now this MME knows the location of the user at least at the tracking area level. Okay. So maybe this specific geographical area, that is tracking area 1, then we have another geographical area here, tracking area 2. And maybe this MME is taking care of both the tracking areas. So since this UE performed attach in tracking area 1, the mobility management entity will create a database entry that, okay, here is the UE with certain identity in Z equals X. And where is that user? Which tracking area? Okay, it is in tracking area number 1. Okay. So we as an MME know the UE location at least at the tracking area level. However, if the power of the user equipment is off, then we have no idea about where the user is. So there is no valid location. Then it is the deregistered state. From the perspective of connection, okay, whenever we have RRC connection in place, and RRC connection is between radio research control, that is between UE and which element? Who will give me the answer? The RRC connection is between UE and some node here. Which is that node? Okay, very good. Thanks for the answer. E node B. So E node B. So we have the RRC connection here. Okay. In RRC connection, we have dedicated signaling connection. Okay. We may have also the traffic bearer, but we have at least the signaling connection, RRC. Normally we establish default bearer. So we also have some radio or traffic bearer. But in any case, RRC tells us that we have a dedicated connection between UE and the E node B in one cell, okay, in some specific cell. Okay. Okay. So if we do have such RRC connection, we are in so-called connected state, and in that connected state, we have full-fledged handover. However, we do have idle state where there is no RRC connection, and in that case, the UE going from one cell to another cell, it is just doing the cell reselection. It is observing the best possible downlink cell. Okay, so we have one comment that this is a little bit confusing. So let me try to bring some clarity. Okay. So let's say power on. Okay, first power off. So then network has no idea. Where user is. So that is called deregistered state. So our UE is in the deregistered state. Okay, so let's say now we do power on. UE will do the synchronization, network acquisition, etc. and it will go ahead and do the attach operation. Okay, and whenever attach operation occurs, then UE and MME, right, they have communication, and now MME creates a database entry, identity of the UE and UE location. So let's say IMZ equals A, and then UE location tracking area number 3. Okay. So now we have taken care of attach operation. So the UE is now in the so-called registered state. It is registered with the MME. Okay. So the MME knows the UE location at least at the tracking area level. Now, when the UE is in the registered state, there may not be any RRC connection, or there may be RRC connection. Okay. If RRC connection exists, terminal is in the connected state. So within the registered state, the terminal is in the connected state. So we can do data transfer, we can do the actual handover, etc. Okay, no RRC connection. So here the terminal is in the idle state, idle mode. We are still registered. MME still knows about us, but we are in the idle state, so no data transfer. Okay. The only thing you is doing is observing the best downlink cell for a potential page message. And of course, if we need to do some data transfer, then we will access the E node B on the random using random access channel. Physical random access channel. So hopefully this brings clarity. Okay, very good. And thanks for your comment. So anytime you want clarity, more details, just type away your question. Okay. Okay. Okay, so now let's talk about the handover within the MME. So we have this MME taking care of these two base stations. Before the handover, our UE is talking to E node B1, and at that time we have the S1 user plane between E node B1 and the serving gateway, and of course we have the S5 interface here between PGW and SGW. So let's say here is some web server. So IP packets are coming from the outside world. They will arrive at the PGW, from PGW to SGW, SGW to this user plane, and down to the user equipment. That is end-to-end path. And for signaling, we have the S1 MME link between E node B and the MME. After we do the handover, it is still the same MME. Right? MME doesn't change because it is intra-MME handover. So we of course need to have new S1 MME barrier between the new E node V and the MME. And of course we need the new data barrier between the new base station and the serving gateway. But same MME, same SGW. So the core network elements not changing. and that's why it is RAN mobility, not the core mobility, but the radio access network mobility. So we would need to do this kind of establishment of new links once we are done with the handover. Okay, and we'll take a look at that kind of handover scenario. Okay. Okay. So let's say we are currently getting our packets through this set of links, ongoing call. And now we are moving toward the new E node B, the target E node B. So during that handover process, we will establish a tunnel between the source and the target. And of course, there is the X2 interface, right, between two E node Bs. In that X2 interface, we have two main functions. One is handover signaling, and another function is packet forward. Now, these are my own acronyms, so it is not in the acronyms list. Handover signaling and packet forwarding. Okay. Handover signaling. So basically, using this, our source will ask the target, that do you have adequate resources to support this handover? So in that case, the target will look at the availability of resources and see if it can support the handover. Not only that, we will forward the packets. So maybe we have this buffer for the user, and there are still some packets that are waiting. We did not send those to the user because we are doing the handover. So those packets would be forwarded to the new target during the handover process. Okay. We want to minimize packet loss and reduce the overall delay. So that's why we are supporting the packet forwarding from the old cell to the new cell, from old E node B to the new E node. Okay. So we will establish that. But once we are done with the handover, once we are fully established in the new E node B, then we will release the X2 barrel, and then we will directly be getting the packets from the serving gateway to the new E node B, and then to the user equipment. That is after the handover is fully completed. After handover, then we have direct communication between target E node B and the serving gateway. But X2 will help us during the handover transition. Okay. So let's take a look at that handover scenario, okay, in detail. Okay. So currently we are talking to the source E node B. We have RRC connection, so we have dedicated communications between you and the source E node B. The source will send the UE RRC reconfiguration message. And that is a generic message that can do a lot of things. And here it is sending information on measurement configuration. So for example, we will tell the user what it should measure, what quantities. So there are two quantities that we can request the UE to measure: RSRP, RSRQ. Reference signal received power and reference signal received quality. So think of RSRP like EC in 1X and 1XC VDO, and think of RSRQ as EC over I naught. So if your UMTS background, then this would be EC over N naught. Okay. And this would be RSCP. Okay, for the pilot channel. This is for the pilot. That's the closest you will get to EC and ECRI not. ECRI not. Okay. But what are exactly those quantities we will discuss in more detail. But let's say at this time that as E node B, we are requesting the UE to measure two quantities, RSRP, RSRQ. We also tell the terminal when terminal should send reports of those measured quantities. There will be some event that we will define. And of course, we'll also look at details of those events. But basically, one event says that our neighboring cell becomes better than our currently serving cell. There is some sort of event. And whenever that event occurs, when neighbor becomes better than the current serving cell, then you will send a measurement report. So that would be one example of how to use the events. Okay, so in summary, to facilitate the handover process, the source node B configures the UE with some measurements. So let's say that maybe some event occurs, and as a result of that event, the UE is sending out a measurement report. And inside the measurement report, we would have the quantities, maybe cell 10 that we are currently talking to has RSRP minus 90 dBm, let's say. RSRP from the neighboring cell 30, maybe that is minus 82 dBm. Okay, so our neighbor is better. Okay. So we are getting this kind of a report from the UE. Now we have a question. ESP, radio bearer, and EPS, are they supposed to be the same? If we have used the term ESP in this session, then probably, oh, sorry. Thanks for your watchful eyes. This is a typo. Yeah, sorry about that. And thanks for finding that typo. EPS. Okay, so no ESP. Just a typo. Okay. Okay. Good. So we basically, as a source, we configure the UE with some measurements, and the UE is now sending us a measurement report. And those reports are basically telling the node B what kind of channel conditions are prevailing at that time. Okay. Now let's take a closer look at both the measurements, RSRP, RSRQ, and this kind of events. Okay. Because we have not yet discussed those. Okay. So RSRP, reference signal received power. Basically, our UE is looking at all the resource elements that carry the reference signal. And reference signal is our pilot. Okay, so resource element that carry the reference signal. So we are taking the average of the power that we measure. So let's quickly review this reference signal. Okay, so let's say this is some cell, physical layer cell number 20. So it is sending out a reference signal. Okay, this is like pilot in 1X, 1XC video, and UMTS. So all the UEs in a cell are looking at the reference signal. And where is the reference signal? So I will give you one example. Okay, let me make it cell 0. That will simplify our discussion and make it accurate. this is slot 0, slot 1, and this is 1 millisecond time interval. So let's say I have so half millisecond slot. If I use a short cyclic prefix about 5 microseconds, how many symbols do I have in one slot? Do you remember? How many symbols in one slot? I have half millisecond slot. How many OFDM symbols? Okay. I got one answer. Okay, another answer. Okay, very good. Okay, 7, 0 through 6. Very good, very good. So symbol 0 all the way up to symbol 6. Okay. So within a slot I have 7 symbols if I use short cyclic prefix, and if you have long cyclic prefix it will be 6. Okay. So I have 7 OFDM symbols within that half millisecond slot. And let's take an example of one resource block. One resource block has certain number of consecutive subcarriers. How many subcarriers in one resource block? Very good. A dozen. Thanks for your answer. A dozen subcarriers. Let's say F0, F1 up to F11. 12 subcarriers I have. 0 to 11. Okay, so now where is my reference signal? Okay, so reference signal, let's say, is here. So one resource element is one subcarrier for the duration of one symbol. That is the definition of a resource element. So this would be the resource element that carries the reference signal. And there would be another one here, F6 during symbol 0 would carry the reference signal, and 6, 5 and 4. Okay, so symbol number 4 F3 and F9. Okay, so within a slot, within one slot, those 4 resource elements are carrying the reference signal. So our UE will measure power on those resource elements and then find the average. So for example, I find, let's say on this one 0.001 microwatts, right? Then I find 0.003 microwatts. Okay. So then if you do the average, okay, you will find 0.002, something like that. So all the resource elements we will measure and find the average. So that would be your RSRP. This is just one resource block, but you will do the same thing for all the resource blocks. So you find the average power on all those resource elements, and that will make it RSRP, reference signal received power. So all the resource elements that carry the reference signal, we find the average of those, some microwatts, nanowatts, whatever it is. So now we know how to calculate RSRP. Finding the RSRQ is now easy. RSRQ would be RSRP multiplied by N. N is the number of resource blocks. So for example, if I have 10 megahertz bandwidth, and if I have requested the user to measure the RSRP across the whole bandwidth, then it would correspond to 50 resource blocks. So N in that case would be 50. Divided by total power that we receive on all the resource blocks. So whatever you measure in your 10 megahertz bandwidth, whatever power you are measuring, okay, on the LTE carrier frequency, that would be your RSSI, receive signal strength indicator, total power. So this is like I naught in 1x and 1x video. It is like N naught in UMTS. The total power that we have in let's say 1.25 megahertz spectrum in case of 1x MDO, total power in 5 megahertz spectrum for UMTS. And in RSRQ, Q is for quality, reference signal received quality. That is correct, received quality. So in summary, we can request the UIT to measure RSRP and RSRQ. Okay. So the terminal will do that for the neighboring cell. And terminal will send a report on those measurements to the eNode B when certain events occur. And now I will give you examples of various events that we have. Okay. So what are the events? Event A1. So this says that our serving cell becomes better than a threshold. So signal RSRP perhaps is becoming better and better. So at some point it exceeds a threshold. So that will be one event, event A1. Another event A2 means that serving cell drops below a threshold. So at this point, right, it is becoming poor quality. Event A3 says that a neighbor is becoming better than the serving cell by some amount. So maybe if this is 3 dB, okay, then at that point we say that event A3 has occurred, because at that time our neighbor becomes better than the currently serving cell by 3 dB. So that would be event A3. Event A4 says that a neighbor becomes better than some threshold. Okay. So at this point, our neighbor is better than a threshold. So good quality can be expected from the neighbor. And finally, the last event that we have defined is A5. A5 means the serving becomes poor and the neighbor becomes better. So in this case, the serving cell has dropped below this. So this is the serving cell. At the same time, the neighbor is becoming better. So better than threshold 2. So at that time, we say that event A5 has occurred at that time. Okay. Can several, now we'll answer some questions that we have received. Several events can occur. Yeah, it is possible, quite possible. But whenever some event occurs, one or more event, okay, then the UE will send measurement report. Okay, but they could occur simultaneously. Yes, quite possible. You know, someone has again faced problems in full screen, and again it is controlled by you and not me. Okay, so what you see on your screen, full screen versus the console view, okay, that depends on you. I have no control over it. So please work with Dan to resolve your problem, but probably you should do whatever you did earlier, right? View and then full screen mode, then hopefully that will get you back. Okay, view, full screen. Okay. Okay. So in summary, there are 5 events defined, A1 through A5. It is up to the E node B to configure the UE with those events. So maybe UE is configured with only A5. So in that case, whenever event A5 occurs, the UE will send measurement report. It is entirely up to the E node B to decide under what circumstances, for which conditions it would like to receive measurement reports from the UE. Okay, so let's say that some event occurred, maybe event A5, and as a result of that, the UE has sent the measurement report. Perhaps in the measurement report we say RSRP for our current cell number 20, okay, is weak. However, we have some neighbor, okay, and the neighbor is pretty good. It is able to offer us maybe minus 82 dBm. So our source E node B has the handover algorithm, and it will make a handover decision. Always remember that the philosophy of LTE is the source makes the handover decision. Keep that in mind always. Source makes the decision. So if you go from cell number 20, that is controlled by, let's say, base station 1, to cell number 30, that is controlled by E node B2, then you are moving this direction, E node B1 to E node B2. So source is this base station 1. So that guy will make the handover decision. Source is making the handover decision. Okay. So in this case, the source has decided that since the neighbor is able to offer better quality, it is a good idea for the terminal to switch to that cell. Now we need to make sure that the target E node B has adequate resources to support the handover. So that's why using the X2 interface, the source is sending the handover request message. And we will identify who the target is, in this case target cell number 30, identity of the UE, globally unique MME ID, which barriers we have established, what kind of QoS we have been providing to the user, and SDW tunnel endpoints, because we have a tunnel between the serving gateway and the E node B, right? So we are providing this end of the tunnel, because the new E node B will need to establish a tunnel, and it can then use that tunnel endpoint. Okay, so that's why it is important to know about the tunnel endpoint. So in this case, as you can observe, we are using the X2 for signaling, right? This is for signaling right now. Handover signaling we are exchanging using the X2 interface. Okay, so now our target will carry out the admission control, will look at availability of resources, and then it will decide that yes, we have resources available. Okay, now let's answer this question. What is the frequency of measurement report and how is it determined? In general, the control is with the E node B. So in this case, where we mentioned measurement report, yes. Okay. As you can see from this slide that when should the terminal send a report, that depends on the events. So when certain events occur, then the terminal will send a measurement report. Okay. So if that event continues to be valid, meaning we stay in the event A5, for example, then we can choose the periodicity of the measurement report as E node B. So E node B is in charge. If events do not occur, measurement reports are not sent. We want to reduce the signaling load. So the measurement reports are sent only when there is a change in the channel condition. So only when some neighbor becomes better or some serving cell becomes worse, something like that. So whenever there is a qualitative change in the environment, then only measurement reports are sent, because it is not based on the time, it is based on the conditions. But once those conditions occur, let's say condition event A5 occurs. So after that event occurs, maybe terminal will send reports every maybe 10 milliseconds or so. But that kind of periodicity is up to the E node B. And how is it determined? Well, it just depends on how many users we have in the cell and so on, because whenever we want to get reports, we need to allocate resources. So if there are a few users in the system, we have a lot of resources available, then probably E node B can use more aggressive reporting. So it will get reports more frequently, maybe every 5 milliseconds rather than every 10. But it will be up to the E node B. And okay. Yes, it is programmable. Yes, the periodicity once the event has occurred is programmable. Yes, that is correct. Okay. Thanks for the question. Keep sending your question. That will make the session customized for you. Okay. So based on the request that has come from the source, the target will look at the resources, and we have said, okay, yes, we have resources available to support the handover. So in that case, the target will send the handover request acknowledgement. In that acknowledgement, we will tell the source which bearers we can admit and which we could not admit. Maybe we ran out of resources. We cannot support that kind of QoS or data rate, something like that. And also there will be some target to the source container. So there will be some data fields, and within that we are providing the UE some important configuration information. We are giving the UE new CRNTI. So if you recall, the cell radio network temporary ID, that is valid only in one cell. So far we have been talking to, let's say, source E node B1 and maybe within cell 20. So we were communicating with source E node B1 inside cell number 20. So the CRNTI that we have received, that is valid only within that specific cell number. This is the physical layer cell ID. So whenever we cross the boundary of the cell as a result of handover, we need to get new CRNTI, and that's what we are doing. New CRNTI. One more important parameter is the preamble. Once the handover is completed, then our UE will send a random access preamble to the target base station. However, we want to reduce delay here. And one way to reduce delay is to minimize contention, right? So that's why we are providing dedicated preamble. So this is the preamble no user will be using inside that cell. That preamble is only for that UE. So this way, no collision, no contention, and it means we can quickly access the cell. Another question, is the resource negotiable or it is yes, no? Yeah, actually it is just yes and no. Okay, there is no real negotiation. Whatever the target can do, right, it will just admit that. So it is yes, no. Because for a given barrel we have certain QS. So if the QS cannot be met, then it will not be admitted. Because we have reserved resources, right, for certain QS, and we have promised such QS guarantee to the user, so we cannot downgrade, for example. Okay. Okay. So now our source has received the acknowledgement for handover from the target, and we can convey the handover decision to the UE. So handover command is sent to the UE. And inside that handover command, of course, we have the container, right, that contains the dedicated preamble and CR and TI for the new cell. So once the UE receives the handover command, then it will stop looking at the old cell. It will synchronize with the new cell, and after some time it will send a preamble to the new cell in the new E node. In the meantime, the radio network and the core network will be working with each other to set up required links. In this case, right now, our source has some undelivered packets, maybe packet P, Q, R, etc. Since we are doing the handover, we could not send those packets to the UE. So those undelivered packets are sent to the target. This is again using the X2 interface. So as you can see, the X2 interface is not only for signaling, but it is also for packet forward during the handover. Okay. And we provide the sequence number information, what uplink packet number we have received, what downlink packet number we have sent to the UE, and so on. So the target is now buffering the packets coming from the source E node. In the meantime, the UE is using the random access preamble, the dedicated, and no contention in that case, and whenever the target can detect that preamble, it will send the random access response. So this way we are establishing the radio link between the UE and the new cell. The target will provide dedicated bandwidth, little bit of bandwidth for the uplink. And since this is the first time we are accessing the new cell, as far as the uplink is concerned, we need to get timing adjustment. Because for OFDMA to work well, we need to have reasonably good timing and frequency synchronization. So all the UEs in a given cell, when they are sending their signals, the received timings of those signals should be approximately the same. So we want to make sure that this new UE who just arrived in that cell, right, is also in sync with every other UE inside that cell. So that's why important to provide the timing alignment. And since we have received the dedicated bandwidth for the uplink, we will use that bandwidth to send the handover confirm message. So this is going now over the physical uplink shared channel, that is your traffic channel. Right? So now we have dedicated connection established. between UE and the target A node B. Let's take care of some questions that we have got. The packet forwarding, is it applicable for the packets buffered at the source? Yes, so whichever packets we have buffered at the source node B, yes, they will be forwarded. That is correct. That is correct. Okay. And what is the duration of handover activity? I do not have any specific numbers, but I would tend to think that it is on the order of tenths of milliseconds. Okay, tenths of milliseconds. That would be the typical number. It should be along the lines of idle to active transition, and for that we have about 100 millisecond target. So my guess is that it would be less than 100 milliseconds. Should MME tracking of UE be updated? Right now, in this case, we just have same MME taking care. Oh, okay. So if we have the same MME, right, then MME will know that, oh, this is the same UE, right? But of course, if there is a change in MME or whatever, then MME will be informed. Yes. Because remember, we have the S1 MME interface between the E node B and MME, right? So we need to, rather than having this link, right? We need to have the new S1 MME. Okay. Okay. Okay, but in terms of tracking area and so on, we should be fine. Okay, because it's same MME. Okay, so the target will tell the MME that we have now established a radio connection with the UE in the new set. So can you please switch the path? So for that, it will provide all the barriers that need to be switched and the tunnel endpoints, because we have here SDW and E node B, right? So we need to provide our side of the tunnel so that SDW can forward the packets to this tunnel rather than the old tunnel. So there's that. The MME will tell the source E node B that I will no longer send you any packets for that UE because we are switching the path. Then it will switch the path, acknowledgement message in response to the request message, and now the packets are coming from SDW to the new E node B. They no longer go to the source E node. So it means that whatever final packets are inside the old base station should be now forwarded. And once that forwarding is done, then the node B will flash the buffer and then it will release the resources. So for example, CRNTI and then the GTP tunnel with the serving gateway and so on, all those resources, radio bearer, right? Everything about the UE that we have stored, the context about the UE, security algorithms and whatnot, everything is now released. Okay. We clear up the memory of the base station for that UE. So now you can see that the packets are traveling from serving gateway to the target node B and over the air interface from target to the user equipment. So the handover is now formally completed. Okay, so now here is the poll question. We are going same MME, and we are going from source E node B to the target, source to the target. So who makes the handover decision? Let's say yellow, red, purple, and blue. So those are the 4 options that you have. I will give you about a minute or so, plus a minute and a half for this question. And please participate in all the polls. And thanks for your cooperation with the new way of submitting your answers. But we do not want you to feel any kind of interruption. Okay, so that's why we have to use this other format. So thanks for your cooperation in this regard. $30 to go. So source to the target. And I gave you one rule regarding who makes the handover decision. What was that rule? Who makes the decision? Ten seconds. Okay. So let's take a look at the colors. I see a lot of red, and that is good news. That is the correct answer. Source. The philosophy of basic UMTS and hence LTE is that source always makes the decision. Okay. And here we are going from source E node B the target. So source E node B will make the handover decision. The network is in control, not the UE. So this kind of handover will be UE assisted network controlled handover. Network makes the handover decision, that's why network control. And to help the network, UE provides measurements. So UE assists the network with measurements. So UE assisted network control hard handover. Okay. One more question coming your way. So let me give you some colors here. Let's say blue, red, purple, and yellow. So let's aim for about a minute and a half for this question. And remember, we are talking about LTE. Okay, do not think about DO. Think about LTE. Okay, so that's what we are asking the question. For LTE, which is a good measurement for handover? And once we are done with this poll, then we will answer some questions and address some comments also. And thank you very much for participation in the polls, and thank you for asking good questions. Okay. 30 more seconds. The questions are pretty good. Okay. So the correct answer, lot of blue. I'm seeing a lot of blue color here. So that's good. RSRP. In fact, that's what we saw in the presidential election on the electoral map. Lot of blue, very little red. Reference signal receive power. So that's very, very important measurement. And another measurement is RSRQ. So RSRP, RSRQ, those are the two measurements that are useful for LTE handover. Okay, now let's address some questions that we have received. So now and of course you can see the questions in the questions box. Even if source decides, doesn't target decide whether to grant it or not? Okay. Handover decision, whether terminal should stay with me or go somewhere else. That is handover decision, and that is made by the source inward being. Of course, handover may fail, meaning the target does not have resources, then that handover will fail. But the decision of handover was made by the source. Okay. But you are right. Whether to grant the request or not, of course, target will decide based on availability of resources. Is there any handoff versus handover? Let the record state that there is no difference between handoff and handover. Same thing. So in LTE, since it is based on UMTS, it's release 8 feature of UMTS. In UMTS, there is nothing called handoff. They call everything handover. Okay. So even when we have UE communicating with multiple cells, multiple base stations at the same time, that is soft handoff. That is called soft handover. Okay. So handoff, handover, same thing. But the term that we use in UMTS is handover. The term we use in 1X and DO is handoff. Okay, but do not differentiate between the two. Same thing. If you want to be formal for LTE, it is handover. Okay, how does the mobile, not the mobile, how does the system handle? Oh, so let's say one U is on the border between two inward with same measurements. The way these events are defined, the result of that would be UA will stay with the source, so there will not be handover because the new cell has to be better than the old cell by certain amount, by some dB, for example. So if you have similar measurements, then you stay with the same source E node B. So no handover in that case. Is this the only type of handover supported in LTE? Yes. Absolutely correct. UE assisted network control handover. So there is no soft or softer handover. UE communicates with a single cell, not even E node B, single cell. We cannot even have multiple cells in the communication with UE. Okay. Same cell, a single cell communicates with the UE. Okay. So this is the only kind supported in LTE. That is correct. Okay, time for a short break, but of course, while you're on the break, think about the question. Okay, and we will unmute the bridge when you come back, and hopefully we will not have any noise problems. Okay, and then you have one more medium of asking questions. So we will resume in 10 minutes.